It's 2065, and you're standing on the moon's dusty surface, working away on the latest array of solar panels to help fuel the local town's energy grid. Suddenly, the surface begins to shake. Is this a moonquake? Or are those moon-born teenagers having a party in the town hall again? You look up at Earth. You're so used to it, you barely even notice it anymore. But now, it looks different. It takes you a few moments to work out why. It appears to be shrinking. You begin to panic. The Earth is moving away. The ground rumbles again, and you work out what's happening. The Earth isn't moving, but what you're standing on is. The moon has broken off its orbit and it's heading out into deep space. Destination unknown. The strange thing is, it's happening right now, and has been for a very long time. It's even affecting how long our days are. Eventually, it will pull away altogether and dramatically affect our planet's oceans. To explore what will happen, let's go back a little, to put it all into perspective. The moon has been hanging around us, literally, for 4.51 billion years. There are a few theories as to how the moon came into being. The main one is that it formed when a large object smashed into the young Earth. The early solar system was a chaotic place. A number of stellar bodies were created that didn't make it into a full planet. One of these bodies, as large as Mars, smashed into Earth, throwing huge chunks of our planet's crust into space. Gravity took over and tied these separate elements together. This explains why the moon is made of lighter particles than we find here on Earth. Billions of years later, and we're more than used to having the moon with us. It affects so much of our everyday life. The obvious one is tidal motion. The gravitational pull or tidal force that the moon exerts on our planet creates the tides. This force causes all of the water on the Earth's surface that's closest to the moon to bulge out to one side. A very short explanation is that it pushes in from the top of our planet and also the bottom, while pushing out from the sides at the same time. The Earth also has an effect on the moon, which we'll get into in a minute. But it appears that the moon might not like our company as much as we might think. It's slowly drifting away from us, even as we speak. The moon can seem small or large depending on the lunar cycle, but in actuality, it's just over a quarter or 27% of the size of Earth. The diameter of the moon's orbit around us is nearly 477,213 miles, but this diameter is increasing by 1.5 inches every year, which of course means that it's moving away by a factor of 1.5 inches each year. To help explain why we have to analyze our relationship to the moon a bit more closely, both celestial bodies are tidally locked. We are synced up in such a way that we always see the same side of the moon. The hemisphere that we never see is often referred to as the dark side, but that's not quite right. As the moon orbits Earth, different parts are in sunlight or darkness at varying times. This change in illumination is the moon going through its various phases. The tidal forces not only affect our oceans, but the body of the Earth too. Because the Earth is more rigid in structure than water, the tides on more solid matter, like the Earth's crust, have a much smaller effect. The tidal forces are interdependent. The gravitational field of the Earth will also apply tides in the body of the moon. Again, because we're not talking about fluid, the effect is very small, but it's there. This interchange of tides is quite complex. Interiors of both bodies are heated by these tides, just as the force applied to any object can create friction or its own heat. Take the planet Jupiter, for example, and its moon, Io. The tidal forces of the giant planet are so huge that the surface of Io, which is solid, is raised and lowered several hundred feet in each rotational period. The heat generated means that the interior of Io is most likely molten. As a result, the surface of Io is covered with active volcanoes. It's one of the most geologically chaotic places in our solar system. Despite its heat, it's definitely not the place to take the family for a summer holiday. Back to Earth. Our planet rotates on its axis once every 24 hours, and the Moon performs one revolution around us in 27.3 days. The bulge on Earth actually speeds up the Moon. The Earth pulls the Moon ahead in its orbit. In other words, the Earth's bulge increases the radius of the Moon's orbit around us. While this is happening, the Moon pulls back on the tidal bulge of the Earth, slowing its rotational speed, though just a fraction. A very small fraction. This means that 100 years from now, a day on Earth will be 2 milliseconds longer than it is right now. Blink and you'll miss it. Literally. In addition, since the Earth is larger, the gravitational pull is stronger, causing the Moon to speed up slowly. As time passes, its orbit will become bigger and bigger. This takes us back to that measurement of 1.5 inches. It may not seem like a lot, but over a period of time, this measurement becomes significant. Let's jump forwards billions of years from now, where we see that the Moon's orbit is so big that it does leave the pleasure of our company permanently. What happens to our oceans then? You've already guessed it. The tides will cease to be. That will make for very calm seas for any boat trips. That's if there are any humans left in, 50 billion years. Before that time, because of the tidal locking slowing down the Earth's rotational speed, it's possible that the Earth will slow down enough to permanently face the Moon. In turn, it may prevent the Moon from moving away from us. Imagine the effect on our planet if we stop rotating. One half will always be in darkness, the other in light. That'll play havoc on our seasons and the natural life. While it sounds dramatic, and the loss of tides would be a significant phenomenon, there are other more serious things to worry about occurring before then. In a tenth of that time, 5 billion years, our Sun will likely consume both the Moon and the Earth. Yep, our Sun is going to have a galaxy-sized party, the likes of which our solar system has never seen, and everyone's invited. The Sun is continually burning the hydrogen in its core into helium. Right now, it's approximately halfway through its life cycle. Towards the end, it will run out of hydrogen in its core. The Sun will ultimately become a red giant. Its surface is predicted to reach Mars. That's when gravitational forces will take over. The Earth will be dragged into this new Sun and disintegrate. The Sun gets 10% brighter every billion years. So long before the planet is totally destroyed, the heat will have melted any ice and fried almost everything living. All of our oceans will have dried up too. So, while the planet has a 5 billion year life cycle yet, everything living on it may only have a billion. To recap, the Moon may move from the Earth, but the Sun will have wiped out both long before the tides are halted. Let's steer away from that hot object and return to that sibling-like relationship of the Moon and Earth. The fact that the Moon has the same rotational period as the orbital period of both the Earth and the Moon is no coincidence. Over billions of years, the tidal coupling of the two has led to the synchronization we know today, and yet it's still evolving. The Earth is slowing its rotational period. Eventually, it will match that of the Moon, and they will be exact. And as I mentioned before, the days on Earth will become longer as well, by 2 milliseconds every century. To have a significant impact, it will take many thousands of years. However, it's nice to think that both the Earth and the Moon affect each other in many powerful and beneficial ways. It's almost like they're simply hanging out together, like a couple of old intergalactic buddies.
It all started with a minor change on our planet. At first, people noticed the Moon had become brighter and a little bigger, but nobody paid attention to this. The Moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet, but something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into 2 parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Now, what would Earth look like if it was the only planet in the solar system? Or, what would happen to our planet if the moon went missing? Or, what if dinosaurs had never gone extinct? We've all heard the story. Over 66 million years ago, a big asteroid hit Earth. Almost 75% of creatures that roamed the planet at the time were wiped out in mass extinction. Among them, dinosaurs. Tyrannosaurus, Triceratops, Velociraptor, all gone. But because of that, we're all alive. According to science, the human race was developing more safely without these gigantic creatures hunting us. But what if that asteroid had crashed to the ground a few miles away from the place where it fell? What would the world be like today? Imagine walking down the street to your local supermarket and coming across a truck-sized T-Rex. Could that ever happen in this alternate universe we're talking about? Well, dinosaurs would have had to survive a lot more than an asteroid to be living nowadays. About 55 million years ago, the temperatures on the planet rose. The climate became 14 degrees Fahrenheit hotter than it is today. Rainforests flourished, and vegetation was abundant. In this scenario, herbivore dinosaurs would have likely thrived. But they would have started to look a bit different. Plants started growing during that time period were not very rich in nutrients. This means that dinosaurs would have probably shrunk in size, not having the necessary energy to grow all the way to their full size. Then, about 34 million years ago, South America and Antarctica split, which resulted in a cooler and drier climate. During this period, long-legged dinosaurs would have been the ones to survive. At that time, animals had to travel long distances to hunt, since seasons started to affect the availability of food and water. Compared to the mammals of that period, dinosaurs would have had significant advantages, like having more teeth or better eyesight. And speaking of mammals, some of them probably would have never evolved. That would have become dinosaurs' breakfast first. By the way, did you know that some dinosaurs live among us today? Think pigeons or birds in general. They've all evolved from dinosaurs. Now, I bet you've heard once or twice that we use 10% of our brains. If this was true, what would happen if you used 100% of our brain? Would you be able to compose a symphony? Would you become a tech genius and create a multi-million-dollar company overnight? Let's start with the facts. We don't only use 10% of our brain. This notion became highly popularized by movies, but it's not very accurate. The truth is, the largest portion of your brain is active at all times. But not all parts are working simultaneously. The exact percentage varies from person to person. Now, neurologists say you wouldn't be using 100% of your brain's capacity at once. Your body simply wouldn't have enough energy for that, which means you'd be hungry all the time. Imagine the number of calories you need to consume for that to work. You would also be limited by your body's basic needs: breathing, digesting food, and circulating blood. So if you did use all of the capacity of your brain, you'd be tired all the time. It'd be worse than running a marathon without any preparation. The brain would need all the blood you'd have, which would mean less oxygen for your lungs. Different organs would begin to shut down one by one. In a nutshell, it'd be terrible for your health. By the way, some researchers have estimated that more than 60% of the brain is composed of something that is called neural dark matter. In other words, this dark matter consists of neurons that have no apparent purpose or simply don't respond to common stimuli. Marathons are some of the greatest feats of strength and endurance in the world, but what would happen to your body if you decided to run a marathon without any training? The statistics are overwhelming. Nearly 50% of participants drop out of the race before crossing the finish line. A regular marathon is 26 miles long, and if you're not used to physical activity, it's a great challenge. You'd probably be able to run the first mile without any serious problems, but breathing loudly and heavily through your mouth. By the third mile, your body temperature would skyrocket, and you'd feel as if you have a mild fever. You'd most likely give up here, but if you decided to keep going, you'd have to trick your mind and body into running another 23 miles. By the 20th mile, you'd hit what is known as the wall. Your body would have burned all your reserves of glucose, and you'd get extremely tired. Even experienced runners often go through this stage. By the end of the marathon, you'd be promising yourself to never do this again. You'd leave the race with at least a few cramps and many food cravings. Now picture this. It's a clear, beautiful night. There are no clouds, and you can see two of the brightest planets in Earth's sky blinking up there. Those are Mars and Venus. Now, have you ever imagined what would happen if Earth was the only planet in the solar system? If the other planets never existed, things would be really different for our Earth. The planets in the solar system work together, keeping one another in certain place with their gravitational pull. Now, if Mercury or Venus ceased to exist, Earth would drift closer to the Sun. Our atmospheric temperature would become similar to that on the surface of Mercury, 800 degrees Fahrenheit. This would make life on Earth impossible, but if Jupiter or Saturn disappeared, Earth would most likely drift further away from the Sun, and its temperature would drop to below -200 degrees Fahrenheit. If life managed to survive in such circumstances, it would probably be aquatic. The position of Earth in the solar system not only affects all kinds of life forms, but it also dictates seasons, the length of days, and how long one year lasts. Now, when we say no other planets, we mean no moons either. So, what would happen if one fine day the moon just disappeared? That would have catastrophic consequences. The moon has the largest influence on Earth's tides. In a moonless universe, tides would shrink by about 75%. This would greatly affect crabs, mussels, and sea snails that live in tidal zones. This would consequently disrupt the diet of larger animals. Eventually, it would affect entire coastal ecosystems. Earth's weather would change. Tides and tidal currents help mix cold Arctic water with warmer water from the tropics, stabilizing the climate worldwide. Weather forecasting would become almost impossible, and the average difference between the hottest and coldest places on Earth would become extreme. The absence of the moon would also influence Earth's tilt. Right now, Earth tilts on its axis at 23.5 degrees, mostly due to the moon's gravity. With no moon around, Earth's axis would wobble between 10 to 45 degrees. Scientists believe that even a slight difference in Earth's tilt can cause huge changes, such as an ice age. Other than this, a moonless sky would upend the lives of many nocturnal animals. Moths have evolved to navigate using the light of the moon and stars. Newborn baby turtles use the moon's light to find their way to the ocean. Different animals rely on both darkness and a small amount of moonlight to hunt effectively. Now, how about we travel far back in time and imagine what would happen if you lived in ancient Egypt? This civilization lasted for over 3,000 years. Ancient Egyptians were responsible for building some of the world's most recognizable symbols, the Great Pyramids at Giza. If you'd lived in ancient Egypt, you'd have witnessed a time of enormous scientific and mathematical breakthroughs. Ancient Egyptians organized themselves in strict social structures, so you'd probably have to fit into one of them. You'd have either been born a laborer, a farmer, or a specialist, which was either a soldier, a sailor, or a teacher, or you'd have been part of the Egyptian elite. If you had been a farmer, you'd probably live in a house made of mud bricks. You'd have had a stone oven and kept your food stored in a pit in the ground. You'd have spent your days tending to crop fields by the Nile River, or taking care of cattle and ducks. On tax days, you'd have packed up some of your harvest and brought it to the temple as payment for the usage of land. If you'd been a member of the elite, you'd have spent most of your days in banquets. You would have adorned yourself in gold and semi-precious stones, displaying all your wealth. If you had lived in ancient Egypt, maybe you would have been one of those who invented tables. Yep, before the Egyptians, there was no such thing as a table. This invention appeared as a way to keep food off the ground.